All right, in this lesson we're going to start talking about Riemann sums, and we always start off talking about right and left-handed Riemann sums. Again, when you are learning about derivatives, it's only natural that you learn about the inverse of that, which is going to be integrals, and we're going to do those in the next couple of lessons. Before you do integrals, you usually talk about something called a Riemann sum, and just like in the previous lesson, you were talking about finding the area under a curve. And now today that area under the curve is not going to be exactly a shape that we know. Like the previous lesson, we had triangles, trapezoids, rectangles. But what we're going to do is divide the area into shapes so we can approximate the area. So we're going to use right and left-handed rectangles to find the area. And we're going to do each kind. If you had different color pens, this would be an excellent time to use them. Speaking of which, I'm grabbing one right now. I'm going to grab red. And so we're going to make rectangles. We're going from 0 to 5. That's the end of our picture. Yours is a little bit bigger picture. Mine's just on a larger XY chart here. And so I'm going to make 5 different rectangles, all with a width of 1. And we're going to find the area of each one of them under this curve. So the first rectangle, what I'm going to do is talk about making a stick. So from 0 to 1 is my first stick. And the idea is that that stick is going to rise up. It's going to like float up until it hits the function. And then you kind of have to decide where do you want it to hit the function. When you are doing a right-handed Riemann sum, you want the right corner of the rectangle you're about to make to hit the function. So you lift this right corner up until you hit the function and then make your rectangle. Doing it again, here's my second little stick. The stick is going to lift up until the right corner touches the function and then make my box, make my rectangle. Next one looks like this. Take 3 all the way up till it hits and across. That rectangle just happens to be higher than the curve. Next one right here. This side's going to lift until it hits. And the last one, making that kind of stick, it's going to float up until it hits there and then across. So our job now is to find the area of each one of those rectangles. And finding area of a rectangle is pretty slick because you just do base times height. And I don't know why I just wrote a 2 there. The width of our rectangles is 1. So the width of all these rectangles is going to be 1. And then the height is what changes each time, how tall each one of those boxes is. So the first one is a height of 4. And then we have a height of 3. And then a 5. And then a 7. And then a 6, for a total of 25 units squared of area. When you go to do left-handed, it is exactly the same concept, except you are going to let, when you look at that stick, I probably should have done red first, you won't be able to see this very well, but here's my stick. When I lift it up, we want the left side to go up until it hits the function and then make the rectangle. So that box is actually a little bit above the line. So right-handed the box was below, and on this one the left hand is above. Here's my next stick, raising it up till I hit right there. Next stick, raising it up. Next one will go right there. And the last one is right here, lifting up the left side. There's my last one. So finding the area of all those, we've got a 1 by 6, a 1 by 4, a 1 by 3, a 1 by 5, and a 1 by 7. It happens that they're both the same. That doesn't happen very often, so maybe make yourself a note in your notes. We don't usually get them where they match left and right. This one just happened to work out that way I drew that line for you. So you are working on finding left-handed and right-handed Riemann sums. It's a crude way of finding area. It's never quite right. There's always too much or too little area. You're always either above the line or below the line. So if you want a better approximation, you have to use more rectangles. So maybe over that same amount of space we'd use 10 rectangles and we'd squeeze them in here and we'd get an even better approximation. The idea is getting to the place where we use an infinite amount of rectangles. So many rectangles that you can't even tell that you're missing the line. You're going to get so close to the line you'll be right on it. So here we're going to do a left and a right hand again, and you have this lovely graph to use. A lot of notation here. All it is telling you that you're going to sum up, you're going to add up all of the rectangles with a base and a height. They're telling you you're going to make 5 rectangles. That number would go right there, 5 rectangles, from -6 to 4. So if you were to count from -6 to 4, you would find out that that's a space of 10. And if I'm supposed to have 5 rectangles, it means all my rectangles are going to have a width of 2 this time. So my area And we'll do right-handed first. My area, all of them are going to be 2 times something. And I'm going to have 5 of them that I have to find. 4 and 5. So everybody's going to be a width of 2, and now I just need to make the rectangles. So I'm going to start at -6, make my stick, and right-handed means the right corner is going to float up, and then make the rectangle. Next one, when I make that stick, the right corner can't go anywhere. It's already on the function, so that's just a flat 1, and it has no height, so 0. Sorry, and this one was a 2. Next one, when I make that stick, it lays right here, and the right corner would actually go down. I think that's to 1.5. And when you do that, you need to make sure you do a -1.5 because we are going below the x-axis, and that area we need to subtract off. Next stick looks like this, lifting the right corner of the stick up. Looks like it's 3. Last one is right here, lifting this corner up. Looks like it's going to be 5. For a total of 4, 3, 13. Nope, 17. I just did that again. 17. We've got left-handed now, so doing the area here. We're going to do the same thing, only we're going to have our stick raise from the left-hand corner. The width of our rectangles is still the same, so that's not going to change. We still need to make them 2 wide. We just need to make them lift from the left. So here's my stick laying on the ground. I'm going to lift up the left side, and that looks like it's a height of 3. Next one, here's my next stick, lifting up the left side, has it at a 2. Next one, here's my stick, but the left corner is already on the function, so that one's going to be my 0. That one's just the flat one. Next one here, it's going to lift, sorry, it's going to go down right there. So we've got a 2 times our -1.5. And the last one, here's the stick, lift up, and that one looks like a 3. So we've got 6 and 4, and we got to subtract this guy, and then we've got another 6 for a total of 13 units squared. Last, we're going to do a right and a left-handed Riemann sum on this equation now. This time you don't have a graph to look at, you just have an equation to work with. And we don't really need the graph per se, we just need to know how high these boxes are going to go. And all of the height of every single point is determined by the equation, by you just plugging in a value and then you find your y value. So we're going to start off by making an xy chart. And we're supposed to go from 0 to 8. Squeezing them all in there. And I'll start with 0, plugging it in, and I get a 4. Plug a 1 in, I get 6, and we're just going up by 2s. Alright, now we're supposed to do a right-handed and a left-handed, one of each. I don't need to make the graph, you can, but as you can see your y values are going to pretty quickly push you right off the graph. So you're going to need to rely more on the x and y chart than you will a picture where you're drawing the rectangles. What I am going to do is just kind of chop this up into 8 so that I can think about what the boxes are going to look like, what the rectangles are going to look like. So I'm going from 0 to 8. I'm supposed to make 8 rectangles, which means they're all going to have a width of 1. So the first one, when I make that stick, I'm raising up the right side, so I'm going to raise up the 1. So I need to know how high 1 will go when I plug it in. So it's 1 wide, and then if I plug in a 1, I got 6. So I know how high that box is going to go. The next one, the right-hand side, will be the 2. So using the 2 value, I've got 8, 10, 12, 14, 16, 18, and 20. So those are my 8 rectangles going right across. Sorry, this is supposed to be an 8. Going right across my XY chart, adding all those up, I get 104. When I do left-handed, what will change is when I put the stick on there, I want to actually raise up 0. So I'm going to use 0 this time. That's where I'm going to start. And then I'm going to use 6, and 8. So I'm going to kind of be one behind the row up here. I started with 4, but now I'm using 6 and 8 and 10, 12, 14, 16, and 18. And I stop because this is already my 8 triangles. 1, 2, 3, 4, 5, 6, 7, 8. So all I need to do is add all of those up and find out what my area is going to be, which is 87. So there's an instance where my left and my right are pretty different. And your whole object, if you get a picture, is to draw those so that you can tell how high they're going up, either left or right. If you get an equation, you're going to need to use the XY chart. Right-handed will start kind of one number in and go, and left-handed will start right away because you want to use that first value.